Hello everyone. Today we are going to learn about a very simple implementation of linked lists in Java. So what is a linked list first of all? As you can see on your screens, a very simple Google search gives us this image, and this is a very generic structure of a linked list. So the whole list in fact is made up of blocks. Block the first block engine, all block have two parts. Number one is data. The other one would be a pointer or a storage to the next node. So if this whole thing is a linked list, this one A is a node, B is a node, C is a node, D is a node. So A has some data and it also has a pointer that points to node B, and so on and so forth. So there are a multiple of ways you can implement this in Java. Number one would be collection linked list. So this is basically a util library functionality where you can just directly implement a linked list in this fashion. You can but this is a very scaffolded feature, and we do not necessarily want to use it, and that's why we come onto this video. So without further ado, let's just get to the coding part of it all. I'll create a new file called linkedlist.java, and I'll start this code in Java. Yeah. So what we're going to do is we're just going to start building this linked list class. So I'll just go ahead and write that class name, class linked list, and here we have a class. As simple as that. Not really, but yes. So now, since every linked list contains a node, what we can contains a node which in itself is a class. What we can do is write that class in a separate file and import it here, or we can just go ahead and create that same class here that we want. So I'll create a class node, and it will have a few attributes. What will be those attributes is one int value. It will have a value. Let's say the initial value is no, let's take a string. So string value and another reference to a node. Now it doesn't exist yet. So what is happening here is we have a variable type which is node, so it will expect a node class object and a variable name. That's it. But since we do not yet using it anywhere, which gets the value null and breaks the code, this should work. So this is right now just a null kind of pointer. We'll make sure to double down on that. So we'll create a new constructor to give default values to this node. Now this constructor takes a value string n no sorry string value, and then this dot value, which is this value, is equal to value. There. Now let's also initialize the next pointer again for every node. Now since we have that, yeah, then we have our node. So now we have our object, just two paths, one value, one pointer, just a variable that is going to store node for the future, right? A pointer to the future, and the actual future. So let's go back to our linked list class. What do we want here? What do we want here? The first thing that we would want for any linked list is a head, some place that we know and we can start with, which is always in our access, right? So we'll create this as a class variable. So node head. We'll also go ahead and create another constructor for linked list class, and yeah, this will do nothing. Just head is equal to null. It will initialize this, And once we have that, let's create our main function. So public static void main, a string of arguments that it will divide into an array. So now that we have our main function, we're going to go ahead and create an instance of the linked list class, create an object, and try to do some things with it. Now to do that, you just type the class name linked list something. What do you want to name it? Just like we called node next here, but here we're going to initialize some value. So new linked list. That's it. Now we have our linked list. The very first thing that we want to do with this linked list is add a node to it. So I'll just create a function called public non-static, obviously, because we want to attach these functions to instances and not the class itself. So public void add. First, I'll make an add first function, and then I'll make public static, not static, obviously. Public void add last, and both of these functions are going to take in a string value, and they'll eventually create a node with this value and add it to wherever they can on the linked list. First thing we want to do is if head is empty. Now, since we're going to use empty a lot many times, we're just going to go ahead and create a function called isEmpty that returns a Boolean value, and it just does head equal to null. And if I'm going to call this function is empty, so what are we going to do? If it is empty, we're going to just create a new node and add it to head because there's nothing there. So add head is equal to new node with the value. So as you can see, this is the way you declare a value. This is the way you initialize that variable. And here I'm just creating this new node, calling this new node constructor and giving it a value, and this returns me a new node with those value, and next is equal to null. So I'll just create an else condition. If the head is not empty, what we want to do is we want to iterate. We want to iterate from the head to until when temp.next is not equal to null, and whenever we find temp.next is not equal to null, obviously is the end of the file that we reach. That every time there will be a next, we find a node next node, and if it's null, then there is no node, and we are going to add it here. So temp.next is not equal to null. Temp is equal to temp.next. This will help us iterate. Now at this point, temp is at the last value, so temp.next is equal to new node value. This should work. For add first. Now for add last, we're going to do something similar for the empty case. Now obviously we can okay, I'll tell that later. We can kind of mix these up and not have to use this statement again, like twice, which is not recommended. I'll tell you. So anyway, so in this case also, we have to add at last. I made this as last function. This is add last. I went to the last and added. I'm so sorry. And now I'll add the add first function. If it's empty, it's new node. Otherwise, what you got to do is you got to create a new head, kind of temporary head. Temporary head is equal to new node of value, and this value is stored in this new node, and temp head dot next is equal to the current head, and now we'll move the head to temporary head. So this will add the node to the beginning of linked list. So now we have add functions. The next obvious thing will be to add a remove function. Public void remove. What do you want? Do we want to remove a location? Do we want to remove a value? I think we should take a location and just use a for loop to reach there. So if location, we will use non-coding location system. We'll use 1, 2, 3 starting. So the linked list will start from 1. So if location is equal to or smaller than 0, we'll just return and do nothing. So if in a void function you return and do send nothing, it is valid. It kind of ends the process there. It works like a break. Else you want a for loop. So before that you want a temporary node pointer to your head, which you can iterate. You can call it iterator also, whatever you might need to call it. Node iterator is equal to head for I, and I is equal to 0, not 0. We'll start from 1, right? So I is smaller than or equal to location. But before we do that, we need to be in a while loop. So in this while loop, we need another pointer just to iterate over stuff. So I'll just declare int I is equal to 0 or is equal to 1. And while itr is not equal to 0, yeah, that's is not equal to null. And I, which is the second iterator over the location, let's just name it temporary. And this is the actual iterator towards the location context. So if temp is not equal to null and iterator is smaller than or equal to location, and ti is equal to 1, we'll just keep moving. Whatever comes first, we'll keep moving. So temp is equal to temp dot next. We'll close it. Let me see if this has some loopholes or not. So while temp is not equal to null, so iterator will go until the last value of location. Otherwise, if you find it null, okay, so if temp is not equal to null, that means we have broken from this loop and we are at a location instead of being at the end or a null value. So we can just remove it now. So we're at the location. What you want to do is stop just before location, right? Yeah. So why we want to do that, I'll tell you. You'll know just by this logic. What we want to do that is, if we have to delete this node, right? So if you're already on this node, which is temp, how can you delete it? You need to be at this node and now just change the pointer of this thing to here now. But that has a loophole as well. Just implement and then I'll talk about it. So while temp is not equal to null, so temp is equal to temp dot next dot next. So if this is null, if temp dot next is null, stopping just before location, temp is not equal to null, and yeah, we also have to do a temp dot next is not equal to null. You know, so This kind of implements our removal thing. So what happens is, so this node now points to this one, let's say C, instead of pointing to B and then C. But there's a problem. B node still points to the C node. We gotta remove that. So to do that, we have to save it in something. So first what we'll do is, yeah, temp.next temp.next is equal to this. And before we do that, we'll save the current value in some place node. Temp2 is equal to just a temporary storage for the value of B node before we lose the connection, which we do kind of here. So just store temp.next here and then add temp1 dot next equal to just keeping care of anything that might bother us in the future. So we have is empty, we have remove, we have add first. Now we also need a display function just to display the linked list. I'll just go ahead and create that void display. You see, since we have this head outside as a class variable, we're just using it anywhere we want to, and it's smooth. We have access to our head. We have an object of linked list every time we are going to call it. So yeah. So now, yes, I was doing a display, public void display. Let's make it public void display. And this does not do anything as such. This takes while we just need an iterator. itr dot next is not, while itr itself is not equal to null, we'll keep printing the values. Let's just not make it so humongous. System dot out dot print ln, not ln, because we do not want it on each line. We just want itr dot value to be printed. Just close this, take care of syntax. Let's just add another line. If you have stayed until this point in the video and you're thinking, okay, why am I just coding and not looking at anything? I don't know. We'll just debug. This should work. This looks like clean code, right? So public void display. Now that display is ready. What do we need now? Let's just rename it for display ll. I don't know why this is in pink. I have no clue, but this should work. Maybe I'm missing something at the top, some semicolon, some colon something, someone's colon. So let's just add some values to our linked list. Now that we did this before, and we have this linked list class in our object linked list instance in our variable called ll dot add first. The very first thing that I'm going to add is Shivanshu. Maybe not Shivanshu. Just keep it generic. Jack ll dot add first is, this is Java, so no single colons. This is sorry, Jack is add first. Good. I'm a good guy. Jack is also a good guy. So now that we have added everything, Where the heck did this come from? Yes. So ll dot add. Let's just use our last function for once, because why not? Mr. Just to add a salutation to our guy called Jack. Mr. Honorable. So there has been a mishap, ladies and gentlemen. So this will do our stuff. Now we want to display this. I'm not adding the remove button as of now, remove functionality as of now. I'll just go ahead and save it, and let's check how this turns out to be. So I'll just go ahead and compile this class. Java C, you do use that class to compile it. So node head error, because you do not have a semicolon. After that, we have linked list, return type required, linked list, because this is not a constructor. Head equal to null, linked list of Java head equal to null, error, not a statement. Not a statement. We have to return it as well. No, not this. So yeah, that should work. Now more errors. Yes, obviously. Import. We don't really need it. So code die. See, we create everything on our own. Go. ll dot display cannot find symbol ll dot display ll. So yeah, there are a bunch of errors that we are going to go through now. This dot value is equal to value. Where is it? Java 9.6. What a value for a value variable. So this compiled successfully. This was okay. This was okay. Not too many errors. So I'll just run it. Let's see what happens. So we have an endless loop at first. Or do we have a loop at yeah. We have an error in the display function. This is happening because we are not moving forward. You gotta move forward in life, dude. You'll be just stuck there. Next. Sorry about that, guys. Hope it turns out. So we'll just compile that again. Remove all this. Honorable Jack is good guy, Mr. So this we have added at last. So this works, right? So this just goes. Let's do that again. Honorable Mr. Jack is a good guy. Let's add something here because we need some space. Everybody needs some space. Yeah. Now let's also hook in our remove function, and we'll remove the value at 4. So Mr. Honorable Jack is so Jack, good guy, like a robot. So compile it. Honorable Mr. Jack is good guy. We have to display it, dummy. Honorable Mr. Jack is good guy. Nothing was deleted. Nothing was removed. There was nothing removed. So we go to the location, which is 4. Location is smaller than equal to 0. No. Location is equal to temp is equal to head. Temp, I hope it's not equal to null. Temp is not equal to null, and ITR is smaller than location. Location is equal to 4. ITR is 1. Yeah. Temp is equal to temp dot next. It goes on from Honorable Mr. Jack is. It stops at Jack, right? Stops at Jack. Temp is still not equal to null. Temp dot next is not equal to null. Yeah. Temp1 is equal to temp dot next. So temp1 has the value is temp.next, which is so this was the error. So temp is equal to temp.next.next. No, temp.next. This is not the error. Sorry. So temp.next, which is, so currently temp was the jack, and now it points to good. So the number one thing that can be wrong here is the iterator. It's not moving forward. So I think doing this should solve that. But apart from this, something that I did not consider before is, so honorable Mr. Jack is good guy. So let's say we have six elements. We want to reach the fourth element. How many steps we gotta take? Because at the end of the day, this temp is equal to temp.next is kind of a step. So you move 1, 2, 3 to reach the fourth, but we do not want to reach the fourth element. I'm using force as an example, so I'm using force as an example here as well. So we don't necessarily want to reach the fourth one. We want to reach the third one to be able to delete the fourth one. So to reach third one, we need to take 1, 2, 2 steps. So we need to factor that in. And to do that, I'll just reduce the location value where we stop. And I think that should do it. Now we compile this linked list class again, and hopefully it does, which it did. And let's run this. Honorable Mr. Jack is good guy. Honorable Mr. Jack, good guy. So now here is how you implement a complete linked list without using any external library or anything. Just everything is your own code, and you can do stuff with it. Now, obviously, there are many mutations possible for this, for every function that is mentioned here, for the structure that I'm using here. We can discuss those possibilities maybe in a future video. For now, let's call it a day and hopefully see you again. Thank you.